Good morning, everyone. My name is Toshiyuki Shimizu. I'm in charge of system development for Fujitsu supercomputer. I'm here to talk to you about our new CPU, the recently announced A164FX, and my view of ARM HPC ecosystem potential, which will be complemented and accelerated by our A164FX. Let's go over the agenda. Okay. Okay. To start with, I'll go over an ARM world background. Then I'll explain my understanding of the ARM SVE specification and its effectiveness. Third, I'll introduce A164FX. And finally, I discuss the ARM HPC ecosystem future and our work with our partners. Okay. As you know, ARM has been growing dramatically from IoT devices, mobile phones, and more. This growth is not only in hardware, but also in software and services. You all here are working hard to make the ARM ecosystem larger and larger. And by doing so, it has also been growing rapidly in system software and applications. However, there is an area which is currently not well covered: high-performance servers. The market is huge and growing rapidly with newly developed technology like artificial intelligence. You should expand our products and technology in order to further develop ARM technology and ecosystem. Announced last year, ARM invented a new ARM to reach into that market. ARM SVE, Scalable Vector Extension. ARM SVE is a really powerful ISA, instruction-set architecture, which will expand the ARM world into the high-performance servers by promising compatibility and long-lasting support. Fujitsu collaboratively worked with ARM as a lead partner in that development. Okay. Here is an ARM SVE features. SVE supports wide SIMD for both floating point and integer. Various data types of data and operations are supported. This is effective to increase the computational performance for the current applications and also for new emerging applications. Very long SIMD with vector length agnostic, or VLA, assure binary compatibility among platforms and generations. This means that we can use this ISA for many years. ARM SVE is encouraging us to build these high-performance servers and to build the software and applications on them. Supportive specification defined by Linaro, this community, also support the movement. SBSA and SBBR allow us to assure compatibility of system software and sequences among platforms. I believe that we are ready to build the rockets to explore undiscovered planets or markets. Okay. This is our new rocket to discover these new planets, A16-4FX. Now, I'll show our approach or our goals and technologies and specifications. I'll also touch on the new interconnect, TOFU interconnect D, and performance results. Okay. This is our approach to design and develop the A16-4FX. We decided to develop an original CPU core by ourselves to utilize our long experience of CPU development. Floating point calculation performance, memory bandwidth, and power consumption should be optimized for high-performance servers. All of these performance parameters are very important and should not be compromised, especially for the performance of real application. Running on the high-performance servers, the balance of the calculations and bandwidth is very important. We should keep the balance the same as our predecessors. This is our promise. Okay. In addition to this, scalability in both performance and configurations is also important for a super large system like POST-K. In order to use a wider application area, the A16-4FX also supports new functions, FP16 and integer functions. Okay. Again, ARM SVE ISA meets our requirements very well. Okay. Fujitsu has developed and provided supercomputer-capable CPU for years. The CPUs are used for K-computer, Fujitsu Prime HPC supercomputers, FX10 and FX100. A16-4FX will be used for POST-K. The performance of the CPU increased along with generations of silicon technology. To keep pace with performance improvements, we invented and integrated the technologies for each CPU. For the A16-4FX, we employed SVE or wide assembly to increase the core performance. To increase the number of cores, we improved the CMG or core memory group scalable architecture. And in order to increase memory bandwidth, we utilized HBM2. By using these technologies, we made our promises a reality. We keep the byte per flop around 0.4 and 0.5 through the generations. Okay. This figure shows the core peak performance of the A16-4FX by utilizing two pipelines of the 512-bit SIMD and our microarchitectural optimization. The core performance achieves this superior throughput. Newly integrated integer function also works well. This shows the chip scale integration using core memory group architecture. A16-4FX integrates 12 computer cores and 1 assistant core, L2 cache, and dedicated memory controller into the CMG, into a CMG. These tightly coupled cores and other components keep the core running well. At chip integration level, for CMGs, one interconnect controller and an I/O controller are connected by the network on chip. These components share all memory, and coherency is also kept by on-chip directory. If you bind the threads in a process within the CMG, linear speed of up to 48 compute cores can be achieved. Okay. This figure shows how high bandwidth is implemented throughout the chip, from memory to calculation units. This uncompromised bandwidth leads high real application performance. Okay. The HBM2 supports 256 GB per chip, and L2 cache supports 3.6 TB per second. So this high bandwidth is realized throughout the chip. This is very important for the real application performance. Okay. To achieve high scalability in both system size and performance, TOF Interconnect D is also integrated in the A16-4FX. We increased the number of TNIs, or DMA engines. This achieves high injection bandwidth and flexible communication patterns. The barrier resources were also increased to allow flexible collective communication algorithms. To reduce the communication latency, we optimize the direct descriptor and cache injection technology. The performance measurements are shown here. Okay. This shows preliminary performance results on HPC and AI benchmarks. Bars are normalized by our previous CPU, SPARC 16411FX. You can see it's over 2.5 times faster than our previous CPU at all benchmarks. These results are achieved by the combination of ARM SVISA, Fujitsu's microarchitecture, and high bandwidth. The contribution is related to these benchmarks. Okay. This is the summary of A16-4FX. It supports ARM SVE and achieves superior peak performance in both calculation and bandwidth. It shows high efficiency on both HPC and AI benchmarks. In the following sections, I will show our work with partners for the system development, software development, and collaboration with ISVs. Okay. As you may know, Fujitsu is currently developing POST-K, successor to K Computer with Riken. POST-K will be available around 2021. As I announced this June, POST-K CPU, or A16-4FX, was powered on successfully, and now OS is running, and design verification is underway as scheduled. RIKEN also announced the post-K early access program, which will start around second quarter of year 2020 here. Okay. This is a post-K prototype rack. Okay. Okay. This is a system software stack. RIKEN and Fujitsu are developing for post-K. Green part is developed by RIKEN, and others are developed by Fujitsu. Okay. Fujitsu compilers and libraries are optimized for the A16/4FX microarchitecture, and they maximize SVE and HBM2 performance. Fujitsu also works in conjunction with many partners. Okay. Here are the main players who will build the ARM HPC ecosystem. ARM and Linaro here and OpenHPC are working for the ARM HPC ecosystem. Fujitsu is also working as a member of these communities or as a partner. Okay. These are Linaro HPC goals and objectives and derivatives. Fujitsu members are working in these groups and contributing, I believe, that very much. And Masaki develops to measure compilers' performance and quality and received Notable Assignee Award this spring. Okay. This is our plan for application porting and evaluation. We are now in the middle of steps 2 and 3. We've just evaluated the application on Thunder X2 and x86 here. So we are going to the SVE evaluation and ISV collaboration. Here is a list of OSSs we are working on at ARM HPC users group and the latest status. We were able to run many combinations of compilers and applications successfully. We are still working around here. But complete soon, hopefully. This is one of the results of OSS application porting and evaluation. WRF is a very famous methodological application. We evaluated WRF using the condition here and here, and on Thunder X2 and Skylake. And long as you can see that high memory bandwidth of Thunder X2 outperforms the Skylake at the same condition. And longer SIMD allows better performance. Here. These results encourage us and make us think that higher bandwidth and longer SIMD of A16/4FX or ARM SVE would perform better. Okay. So in summary of my presentation today, ARM SVE has opened the doors for ARM ecosystem in high-performance servers. Fujitsu developed A16-4FX as the first implementation of the ARM SVE. It would perform in both HPC and AI applications. POSK will use A16-4FX and will achieve 100-fold application performance of K-computer. Fujitsu will continue to work with our partners for ARM ecosystem from the HPC area. Thank you very much.
Shimizu-san, thank you so much for joining us this morning and sharing that with us. You know, the movement of to ARM of supercomputers is really going to mainstream supercomputers all over the world. There are so many different applications for the use of this, and I think we'll see them proliferate everywhere as a result of the work like the work that Fujitsu is doing. Any questions this morning? Anyone?
So I just want to know, for each CMG, it has 13 cores. All the 13 cores are symmetrical or not?
Sorry, what is 30 core?
The 13 cores in CMG is symmetrical or not? And why it is 12 cores with one assistant core? What's the special consideration for this?
Okay.
Thank you.
So wait a moment, please. Okay. 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 So your question is, I said that 12 computer core and one assistant core. So you symmetry. So you.
Identical. So all the 13 cores are exactly the same or not?
Same. Same cores. You can run the original or ordinary program on the assistant core also. The same core.
Okay, so the next question is, why there are 13 cores? So what's the special consideration to define the 13 cores? For cache coherency or for bandwidth? Any special consideration for this?
So the performance should be considered for the bus bandwidth and number of cores. But it is, that's it. So we compare the bandwidth of the bus and the number of cores. We provide enough bandwidth for each core, so the number of cores is very limited.
Another question, anybody? So you can actually see the first iteration in real life of POSK after the break today next to the Marvell Thunder X2 workstation. Shimizu-san, thank you so much for joining us today.
Thank you very much.
Okay, and now I'd like to introduce Wang, who will talk to us about smart communities. Yes? Please join me in welcoming Wang.
Hello, everyone. I'm Wang from Unisoc. Unisoc is the second largest semiconductor company in China. Today we're talking about smart community development status in China. Smart community is no longer the buzzword. It actually occurs around the globe as we speak. So today we'll share what's happening in China, what kind of challenge you are facing when deploy smart device in the home, community, city, and some resolution to address those challenges. China's builder add over 2 billion square meters of the floor space per year which account for 50% of the new home construction around the world. So the real estate developer in China are motivated to pre-install the smart device and the smart appliance as a standard product to give them a competition advantage over competitor, and more important, to let people live better. For example, the Country Garden, which is the largest real estate developer in China, have developed over 600 smart communities since April 2016. They're working with 40 partners and install over 1,000 different type of the smart device in the home. Here are some examples we can see. This one in Guangzhou, this one in Huizhou, this one is in Shunde, and this one is in Malaysia. So we also have video clip to show what kind of smart community they are developing right now. So let's show the video clip.
Life is made to be easy and convenient. A city of Country Garden, like smart life for you.
Osika exclusively bring all of the security, convenience, and wisdom for your life. Let you enjoy smart life. Create ideal home for you.
Okay, so I think this video clip should give us some idea. First of all, let's look in the smart city because smart community is a part of smart city. Here is a smart city application and the platform. China posed for their leadership role in smart city technology development as rural to urban migration. So China have the highest number of the smart city pilot project. Right now, there's over 1,000 smart city pilot projects ready for or under construction worldwide, and China is home to approximately 500 of them. Take one example, the massive installation of the civilian camera system with advanced facial recognition technology can theoretically scan entire China population of the 1.3 billion people within a second. It helps police to crack down on the criminal and improve the security. If you have been in China, you should be aware that you can wander around at midnight in the downtown of some big city like Beijing, Shanghai, or Shenzhen with assurance of being safe and sound. On the flip side, security and privacy protection are always connect and a key area to deliver the quality of experience. So you do want your facial data in the system to be kept safe and with strict government oversight to prevent any unauthorized use or interception. Then we'll move to smart community. So from the video clip we showed before, you can see the smart community already connect all there is like the electricity, water, air condition, elevator, or this garage, the community gate, and with the system, all the things together, so they can manage your entire community more effectively, more efficiently, and more safely. But how to protect privacy, enhance security, and manage the maintenance and operation cost low will be a major challenge. Here is some typical home with all this smart device installation, like the air purifier, the water purifier, the smart lock, the water leak detection, gas leak detection, or this window control, window sensor, curtain controller. So if, for example, if I have the water leak or gas leak in the home, this the sensor or the gas sensor that can detect and report the issue, and they can remotely shut down the water or gas if there's any leaking in there. So here is looking on the solution overview from the smart device to gateway to cloud and to service provider. There's many challenges between them, but today we focus more on the device to the gateway because as a chip vendor, the device and the gateway is of the bread and butter. Most of these devices are wireless connect to the gateway. There are many different wireless technology in the home, like the Wi-Fi, Bluetooth, Zigbee, the NB-IoT. But the Wi-Fi actually dominates the home, the wireless connection. And also, we believe that will be the case in foreseeable future. So today, we will focus more on the using the Wi-Fi as an example to talk through those challenges between the device and the gateway. So looking on the challenge side. So first of all, it's a coverage challenge. I think everybody experience you have the Wi-Fi some dead zone in your home, like your laundry room, your kitchen, or your backyard. You don't have Wi-Fi connection or the crappy connection, so you suffer all this issue. Most of those smart device or IoT device, they don't have user interface. You cannot input the SSID password. So how to set up those devices will be a key challenge here. And we also need to update those devices from time to time to address any security hole and also the fix issue. So continuous firmware OTA update is critical. And once the device have the trouble or you run into issue, you want to remove the diagnostic of those devices instead of sending the service people to the home. For the chip vendor, we also suffer the fragmentation of the ecosystem and the lack of standardization. There are many different cloud and atolls in here, like the Alibaba Cloud, Embed Cloud, Amazon Cloud. And you have the different atolls. There's Embed, there's Ali Things. And everybody would prefer using their own OS, like Alibaba, they may prefer using the Ali Thing OS. Embed Cloud may prefer using Embedded OS. So as chip vendor, we have to provide a different flavor of the firmware to support the different OS in order to fit into their ecosystem. Okay, so now turn to some resolution to those challenges. We're using Wi-Fi example in here. So we said there's no user interface, so how to connect those devices to the gateway. They have the WPS before, but WPS, we know they have a lot of security hole in the WPS. So Wi-Fi Alliance replaced the WPS with EasyConfig, or called DPP, Device Provisioning Protocol. They can use in smartphone to do two scan, then you can connect, basically using your smartphone to scan the barcode on the access point first to establish the network. Then you're using your phone to scan the device to the provisioning. After these two scans, the device can connect to AP security. As solve the connection issue. Okay, second is solve the coverage issue. So we know the most home, especially in the US or Canada, the single family home, the one AP is not enough, so you need a multiple AP. And in order to roaming and hand over data between those AP, you prefer to use a mesh. If you search Google, there are many different mesh solutions there, like the Google Home, like some startup company like Eero or Prom. But all these mesh implementation are the proprietary implementation, so they cannot work in each other. You have to buy the same device from same vendor. So the WFA created this easy match program that allows the multiple AP from different vendors can interact with each other. And you don't have to change the device. You don't have to change the underlying hardware. You don't have to change the application. Basically, try to solve the issue in the 2.5 layer. They also have this called home design program. What that means is if you need multiple AP, they were based on the home size, your floor plan. They're based on how many occupants in the home, and design the bandwidth for everybody. And you design the desired performance and the latency. So you can decide how much AP you need and where you put those AP. After this design done, they have the tool to generate heat map. The heat map based on this AP and the floor plan, they generate heat map to show you, so you can visualize the Wi-Fi signal in your home. So the green means everything is above your desired performance and the latency and the throughput. The yellow means you're at the edge of that. Red means you're below. So if the red, you have to reshuffle your AP installation, or you add more AP. So that's make sure you have the best coverage in every corner of your home and also your backyard. Now there is remote diagnostic. You don't want to send the service people to home to look into the issue if you run into any the connection issue or the connection loss. So Wi-Fi data element is a set of standardized data model focused on key performance indicator. So once you collect this data, you're able to remote diagnostic to see what happened in there. You can reduce maintenance costs. Also, Unisoc is working on working with standard body, Wi-Fi Alliance, and the China Real Estate Association, and also the home appliance vendor like the Haier Meidi, to try to develop a China Smart Home certification program. So it's allowed. So we talk about the lack of standardization. So we try to create China's own certification program to make sure this smart community, the development is unified. There's over, we said there's over 2 billion square meters of the floor space that is converted to 10 million new homes per year. So there's a lot of the business opportunity in here. Okay, so as Unisoc, so we also try to provide our own solution to help on this development. We have the few things to introduce here. Like first one is this is where we have the demo in the open hour. This is UWP5661. We're working with US Robotics to create a 96 ball. This chip is support 2x2 11AC and plus BT 5.0. It supports long range for Bluetooth. That means you can have up to 800 meters of Bluetooth connection. The Wi-Fi is 2x2 11AC. And we also support the indoor location, Wi-Fi RTT and Bluetooth AOD. So we have two CPU inside, two CM4, one CM4 for Wi-Fi Bluetooth, another CM4 for the vacation. So you can develop a third-party vacation on second CM4. Since this is a 28 nanometer process node, so we can support up to 416 the clock speed, the CPU clock speed. And we have 512 the SRAM. We can hold up to 32 megahertz the flash. So you can do a pretty decent work on your application development. This is some sample we are working with our customer to develop those products. Next one is audio product. This is a single band, the Wi-Fi plus Bluetooth 4.2. This since the 14 nm process node, so sample only run up to 160 megahertz. Some product already shipping on the market, like the speaker, like the storytelling, and the home voice control panel. Those are already shipping today. And this is the Bluetooth audio solution. And we have the quite different audio chip in here. We just showed two of them in here. One is 4.0 support, one is 5.0 support. And this is most for the Bluetooth speaker or the Bluetooth headset. That also include the TWS. Okay, so I think I'm done. Okay, thank you.
Wang, thank you so much.